So let's start implying this idea of inertial frames and non-inertial frames. So first we'll have some car, and we'll say that it's traveling to the right with a velocity v, which is 30 miles per hour. And then we have another car traveling toward it, and this is going to be traveling at some velocity u, which we'll say is the speed is 25 miles per hour. Of course, the velocity is going to be minus 25 miles per hour. Okay, and then we're going to say that the person in this car is going to throw a baseball. Okay, and he's driving, so this isn't going to be a fastball. He's not throwing it very fast, but he can still get it at a pretty good clip. So relative to the person in the car, we say that he's going to throw the ball. Again, not very fast in terms of being able to throw a baseball, but he'll throw it with u of a baseball, and we'll say the velocity, the speed of the baseball is 35 miles per hour. So again, not very fast, but decently fast for somebody who's got another hand on the wheel of a car and they're just launching it from their left hand out the window. Okay. So the first so what we want to find out, okay, is what is the speed of the baseball in the frame of the blue car on the left. Okay, so in the frame of the car on the right, the speed of the baseball is 35 miles per hour. What does it appear to be to the person in the car? Okay, so we have to do this in two steps. The first step, okay, is we want to find the speed. So we want to find UB. I'll actually call this UB double prime here. So we want to find the speed of the ball, UB prime, in the stationary frame. In other words, we have two things going on. First, we have the frame x prime. Well, we have the frame x prime y prime of the car. We have our stationary frame to somebody outside of x and y. And then we also have another frame, x double prime, y double prime, which is the frame that's moving with the other car. Okay, so we have three different reference frames here. Okay, so actually I'll change this then. So this isn't UB prime, this is just UB. This would be UB prime because this is UB in terms of A. So then we can say that, well, UB is going to equal U plus UB prime, right? So the velocity of the baseball in the rest frame is going to be the velocity of the baseball plus, the velocity of the car plus the velocity of the baseball, which in this case is going to be minus 25 miles per hour minus 35 miles per hour, or in other words, minus 60 miles per hour. Okay? And again, that makes sense, right? We're just saying that we're adding the velocities, that it's going to be seem to be, moving, because it initially, before he even threw the ball, it had a velocity of 25 miles per hour because it was traveling with this person in the car. And then he throws it, so we get an additional 35 miles per hour added onto it. So in total, it seems like it's moving at minus 60 miles per hour. So already it's picked up a lot of speed. Okay? Then the next step is going to be to relate to, the x double prime, y double prime frame. Right, so now we go back to our equations again, and so recall that VB double prime is going to be VB minus VB prime in this case. I'm sorry. So the velocity of the ball is going to be the velocity of the ball in the rest frame, which should be UB, minus V, the velocity of the car's frame. And so this is going to be minus 60 miles per hour, minus 30 miles per hour. So relative to the person in the other car, now the baseball is going 90 miles per hour. So while the person in the first car didn't throw the baseball very fast, so the person in the second car is going very fast. And so this is just one example of how we can use inertial frames. And basically another way of looking at this is we're just adding the velocities together. But in doing so, we find out how fast the ball is moving, depending which car you're in.